Have you seen scatter plots before?
Yeah.
Yeah. So the basic premise is, like, when you look at this scatter plot, what do you see?
It looks like a line kind of going,
It kind of looks like a line.
but like with a few.
So if I were to say in general, there's a linear trend.
Yeah.
Okay. So it's linear. It appears to be increasing. And without knowing what X and Y stand for, there's not much more we can say. Other than, like, do you think it's, like, this is showing a relationship between whatever X and Y stand for, right? Does this look like a strong relationship, moderately strong?
Maybe like moderately.
Okay. And are all the points on the same line? All right. Do we know if there was a same line, like, or the best fitting line? How far away are they?
It looks like most of them are not very far.
Most are close. I agree. All right, and so then we're kind of like thinking through, and there is, like, maybe this could be a decent fitting line, right? But it could also be, let's try purple, like this could also is a slightly different line, but that could be a better line. It's hard to say, right? So how do we find what is like the best fitting line is kind of like a weird thing to deal with. So the answer for that is calculation. And when I say calculation, using tech. Most likely the tech you're going to use is your calculator because that's what you have. But like Excel does it as well, so we would use Excel to calculate these lines, okay? All right. So the first topic we want to talk about is this idea of correlation, or R, which I think we talked about R a little bit first semester. So R is just a calculated value. It's in between -1 and +1. Okay? And R equals 0 is a weak relationship. R equals 1 is a strong positive relationship. R equals -1 is a strong negative relationship. All right. So as we look at all of these, we might look at, say, I might be able to look at, say, this graph right here and say, wow, that's a almost perfectly linear relationship. So for that graph, this one, R might equal -1. And for this one, R might equal, well, it's not perfectly linear, but man, those are pretty close to each other. So for that one, we might say 0.95. Versus this one, R would equal, what are you thinking for the...
Maybe like 0.5?
It's probably a little bit stronger than 0.5, and it's negative, right? Because it's going down, okay? So negative, I would actually maybe say 0.7. And this one, I might say R is, well, that one looks positive. Maybe that one might be 0.6. What about this one on the bottom left?
That one is like not close at all. So like maybe closer to 0.
Yeah. I don't look at that and be like, oh, it maybe looks like we have a few more points in these two corners, so maybe positive. So maybe like 0.02 or something. Maybe slightly positive, but yeah, it's pretty murky. And this one maybe, looks at least maybe a little bit negative, just because, again, you see the kind of points in those corners, but not very strong, like maybe -0.2 or something. Now, the deal is that the human eyeball is terrible at judging R. Okay, so when we judge R, it's pretty. Hey, do you want to tell them how hard the pop quiz I'm giving them over this material is?
It's probably going to be really difficult.
Yeah, but for the students who are here, we might even give them like an answer key or something.
I think that's appropriate.
Yeah.
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 I should make
Totally
up a
fair.
pop quiz for tomorrow just to be funny.
Well, I even went.
So some other characteristics about R. Okay, so let's say when I say like it's not affected by transformations, let's say I have a scatter plot where let's go ahead and say the x-axis is gonna be speed and time. Okay, and let's say it has like the faster you go, that would probably have a negative correlation, right? The faster you go, the less time something would take. All right, and let's go ahead and say my speed was measured in miles per hour to begin with. And we might look at this and we might say, oh, that R looks like it's maybe negative 0.9. Because it's pretty strong, right? Negative. All right, what if I took all of those speeds that are currently in miles per hour and turned them into kilometers per hour?
Their place would change on the graph.
Yeah, it might look a little bit more like this, right? But R would still be negative 0.9 because the relationship between the two variables hasn't changed at all. So when we say R is not affected by transformations, that's the kind of transformation we mean. Like if we change the units of something, or if for some reason I put time here and speed here, yeah, the graph would look different, but R would be the same. Okay? We already said between -1 and 1, R equals 0 means not a correlation. If you have, like, let's say we had one weird point where the speed was really fast, but which doesn't make sense at all. If we had a point here, that would greatly change the value for R. Okay? And R can only measure linear relationships. Okay. You will never have to calculate R by hand. It is doable, but if I made you guys do it, you would throw things at me. And I don't like things getting thrown at me. So your calculator is going to do all of this for you. So we don't need to stress about it. Okay. All right. Now, when we have those lines, when we have this data that forms this kind of like linear pattern, we want to be able to calculate the line that fits the best. And there's a lot of things that go into that calculation, okay? But what's lovely about this is you can use the calculator to make predictions. And again, we kind of talked about this in the first semester quite a bit, right? So we have, once we have a line, which we tend to write as y with a hat on it equals, I would think of it as a plus bx. I think on your formula sheet, it's a plus bx. That's not even on the formula sheet, so it doesn't matter. This is the stats way to write it. It's not that different from y equals mx plus b. It's just now, like this little hat tells us we're dealing with predicted values instead of actual values. Like that's the biggest difference. All right, and interpolation is predicting inside the data range. And interpolation is lovely. We like it. Okay. Extrapolation is predicting outside the data range. And that one makes us sad. And typically, like X is the predictor of Y. So when we talk about the data range, what we do is we take a value of X, a possible value of whatever we're using as our x variable. And our x variable is usually the independent variable. And our y variable is dependent. Okay, so the next thing I want us to do is look at using our calculator to do some stuff, okay? So here's a data table. Let's go ahead and put this in Y1, or in L, I don't know why I said Y1. Let's put the year in L1 and the price in L2. Uh-oh. I skipped one. There we go. All right. So, all right. So once we have the data in our calculator, the first thing I want to show you is how we can do the scatter plot. Okay. So if you see where it says stat plot, that means this is where we make statistical graphs. So if I hit second y equals and hit enter, my first option is the scatter plot, okay? And so we just go ahead and go down, make sure the X list is L1 and the Y list is L2, because that's where we placed all the data. And then if you hit zoom and see option number 9 says zoom stat. And hold on, I got some other stuff I want to. We can see a picture of our scatter plot.
So I hit zoom and it's like
And then
weird. It like gave me this little list at the bottom.
yeah, sometimes that happens. Just go back to that empty window and then let's go ahead and clear out the random stuff that you typed in your white ones. Now it's fine. There we go. Okay, and so it's worth noting, okay, so X is the year, so as the year increases, so does the price. Does that make sense?
Yeah.
Yeah, because as the year is increasing, the car is younger. Okay, lovely. All right, and so the next is I'm going to show you how your calculator can find that line of best fit, but before we do that, we have to make sure we got one thing turned on. So if you go ahead and hit the mode button, and I want you to go down where it says stat diagnostics. And like right now we can see that my stat diagnostics are on off. I'm gonna go over and hit on. Okay. All right. Then you're going to hit stack and arrow over to calc, because what we want to do is find the line of best fit. And I'm going to choose option number 8, with a plus bx. Okay? And for right now, let's go ahead and hit calculate. And as you can see, so the equation is in the form a plus bx, where a is negative 1,876,000 some change, plus b is 935. You can see we have our values for r squared and r. R squared, we'll talk about r squared for you guys tomorrow, and then Wednesday for the other group during the block day, about what that r squared really means. But we'll focus on just, right now you can see we have an equation. Here's my equation. I obviously, when I typed this, saw the 952 and didn't see the 9, so let's go ahead and change that to a 9, but we have the right idea here. Okay? All right. So, and we could also, like, I might look at this and see that instead of saying y hat, I might say price hat. It's possible you'll see stuff from me that looks like this, equals negative 186,780.9 plus I think that makes it a little bit easier for me. I like to write equations in context, but you wouldn't need to. This would be fun. Okay. So if I want to make a prediction, essentially what I want to do is I want to know, well, what is the price in 2004? Well, then I'm taking that equation plus, and all I'm going to do is take that equation and replace the year with 2004. So the predicted price, and again, that hat just basically means the predicted price. Okay? And that predicted price would be roughly 78.89 96. Now, it's worth noting that we are allowed to predict for 2004 because 2004 is in this data range, because our data is ranging from 1996 to 2010. Okay? So when I go to do 1994, we're still gonna practice making that prediction, but this is a sad phase. We don't really want to predict for 1994 because 1994 is outside that range of data. And the basic premise is that the predictions become less and less reliable the further you are from your data. Okay? So, but to make that prediction, we would say the predicted price. Again, the hat just means predicted. And notice that we get a ridiculous answer because you can't buy something for a negative amount of money. Cool?